Hello. So we're going to talk about connectors today. So we're going to start off with the XLR connector that ideally most of you know. This is a 3-pin XLR connector. Specifically, this is a Neutrik NC3M. So it is a male connector with 3 pins. This is the gold, so there's another letter in there to indicate that it's gold, another letter to indicate that it's black. There's also a silver version. But for the most part, this is a 3-pin XLR connector. This is one made by Neutrik. And this is a male. This is a female. This is another 3-pin XLR connector made by a company called Redco. They basically cloned the Neutrik connector, except that the boot, this part, is all plastic on the Neutrik, and it's partially metal on the Redco. These are cheaper than these. I like these connectors a lot. The machining is not as perfect. These are a little bit better and tighter, if that matters. These are fine, though, for everything I do with them. And then I've got, again, male and female of both of them. On the ends, and you've all made mic cables, so you might remember this, the pins are labeled. So you can see there the pins are labeled 1, 2, and 3. So here's the Neutrik 3-pin female XLR. Here's a switchcraft version of that. So the Neutrik is nice in that it doesn't require any tools. The switchcraft you have to have a small screwdriver to take it apart. Otherwise, they're interchangeable. They both work great. They both hold up really well. All the ones I've shown so far are cable-in connectors. And again, they're all 3-pin. The fact that it's an XLR is a designation for this particular size, configuration, and style, so that all XLRs will connect together. However, 3-pin is not the only kind of XLR. Here's a 4-pin. 5 pins are also common. I think I have a 5-pin. Yeah, so here's a 5-pin male compared to our 3-pin male. There are 6-pin, there are 8-pin. There are some other other XLRs that are many more pins that some of the mic manufacturers are using, Lewitt, for instance. So again, XLR doesn't tell you this 3-pin. This simply tells you this style of connector. So a 3-pin XLR would be the way to describe this accurately. Again, here's the male connector, here's the female connector. One of the things that I think is important in this context is to talk about the connections that are here. There are 3 of them. There are 3 connections in this connector. We can also say that there are 3 pins. That's typically what we would do. We say this is a 3-pin XLR connector. That means there are 3 connections in it. Pins 1, 2, and 3 are all different connections. This is not a balanced connector. It can be, or it can be used for something else. So there's a connection style called T-power, where instead of using phantom power on a balanced line, one of these pins was ground, pin 1. Pin 2 was audio, unbalanced. Pin 3 was 12 volts. And because it wasn't phantom power, you could send more current down it. So they offset unbalanced by having a hotter signal level because they could send more current through to power the microphone. So that was used quite a bit in older style microphones, but it's basically been phased out for phantom power. You could also use this for headphones, for instance. So we use it in one of our studios at IU. Actually, both of our studios at IU, we use these to power headphones. We have ground and then left and right. Make sure I'm pointing the right numbers. I was doing that backwards. Ground on one, and then left, and then right. So this in itself is not balanced. The system is balanced. You need a balanced send, balanced device on the output, and a balanced receiver. So a balanced transmitter and a balanced receiver to make a balanced line. You also need a cable and a connector that can handle 3 connections, or at least 3 connections. This connector can do that, but it in of itself is not balanced. One of the things we do is we'll tend to call something a mic cable if it has 3-pin XLRs on both ends. It can be used for microphone balance signal. It could also be used for line level balance signal or headphones or anything you want. It's just a 3-pin connector that has a shielded cable on it. So not all 3-conductor cables will work for balanced lines, but that gets a little more complicated than I want to talk about right now. So just noting that this is a 3-connection or 3-pin connector, and you can use those 3 pins for anything you want. In addition, all XLRs have a 4th connection. Well, I should say an additional connection beyond the number that it gives. So this is a 3-pin. And take it apart. Here's where you solder the 3 wires. There's also this tab, this additional, and all XLRs have these. And this, in this case, has a little clip on it that's going to connect to the metal of the housing. In some cases, there's a screw that comes out that does that connection. But this is connected to the physical outside of the XLR. So you can use that as a 4th connection if you want. It needs to be ground because it's connected to the outside of the connector. That means that when you plug it in to a chassis jack, which is what this is, that's going to connect to the metal housing of the jack, and that's going to be touching the chassis of the piece of equipment. And here's that connection right here. We can solder that plus our 3 normal XLR connections. So you can't have a 4th connection if you want with an XLR. Again, for a 3-pin XLR. If you had a like this 5-pin XLR, the shell would give me a 6th connection that could be ground. Now, all of the systems I know of that use XLRs use one of the pins for ground, and then possibly the shell as well. Sometimes the shell might be only chassis or shielding, where pin 1 might be an audio ground or something separate. So that's a way we might deal with different grounds if we needed to. Most of the time, though, the shell and ground are going to be connected together. But that is an extra connection on any XLR that you have. So there's a chassis mount female. Here's a PC board mount, chassis mount female. So that just connects to a circuit board, where this connects to wires. Just to let you see a couple options there. So those are XLRs. We're going to use XLRs a lot. That's the basics of them, though. The other connector we use a lot are 1/4 inch, like this. So this is a tip ring sleeve 1/4 inch. So we've got the 3 connections. We've got the tip connection, we've got the ring and the sleeve. So TRS, tip ring sleeve. This is a Switchcraft model. I don't think I have a Neutrik sitting right here. This is a different brand. Same basic idea though. Got your 3 connections. This is not Neutrik, but I don't remember what brand this is. It's just one that was sitting in my shop. So there are 3 connections coming through here. The tip comes through in the very center, and the ring is a circle around it. So when you're looking at it from here, trying to figure out how to connect it. So when you're looking at it from here, trying to figure out how to connect it, this side right here connects to this pin that goes straight through the middle, so that's going to be tip. This one that's the second down, connecting to something that's slightly bigger than this that connects to here. So this is going to be tip, this is going to be ring, and this is going to be sleeve back here. You can always use a digital multimeter to confirm, make sure you know what you're connecting to, but that's the 1/4 inch. That's cable end. This is the chassis connector. So with a chassis connector, we have 6 connections on the bottom of it. And this is for a tip ring sleeve with normals. So as we plug in, notice these move up. So those are now spring loaded against the connector. So we've got tip, ring, and sleeve. And that's these three. The other three right now are not connected to anything. But if I take this out, then my tip, ring, and sleeve on this side that go into my piece of equipment are now connected to this side. So that's normal. When nothing's plugged in, this is connected to this is connected to this, and this is connected to this. The most common way to use that is, at least for tip, to have its normal connect to ground. So if nothing's plugged in, your positive signal, and if it's balanced, you would be positive and negative both, hot and cold both, would connect to ground in the normal. That means when nothing's plugged into here, you get any noise or signal getting into your unit. So particularly for like a guitar amp, that's really useful to have the tip shorted to ground when nothing's plugged in. That way it's not noisy. One other neat 1/4 inch you might see, so this is a special switching 1/4 inch plug. So these are particularly useful for guitar players. So there's this little switch here. There are a couple different ways I've seen this done, but this is the one I like the best. This is a Switchcraft, really expensive connector. When this is plugged in to something, that pushes in. So this little part here is going to push in when it's plugged in. What that does is connect the tip and the sleeve. There's no ring on this. It's just unbalanced. Well, this is just, sorry, I made my own mistake there. This is just 2 conductor, so it would be used for an unbalanced line. So we're connecting hot and ground together when this is not plugged into anything. So if the other end of this cable is plugged into a guitar amp, you switch guitars, as soon as you unplug, hot shorts to ground, there's no noise, you plug back in, it turns back on. So this is like a mute whenever the guitar isn't plugged in. So you can do a quick guitar change, even with pretty hot guitar signal, lots of distortion, lots of gain, and you're not going to hear it really turn on and off. You're not going to get that big click or thump that you normally would if you just unplug a guitar. So really useful. Again, these are not inexpensive connectors at all. This particular one also has a really nice additional strain relief to help with the cable. So it's a really nice, if you ever want a really, really good guitar cable, build one with one of these on one end. The other connector that we use a lot in audio now are the DB25 connectors. So this was originally a connector used for computers for parallel interfaces. So they're still used for audio because they're inexpensive. So this has 25 pins on it. That's why it's called DB25. There are also DB9 and other connectors. DB25 is the one we use for audio quite often. 25 connections means that we can do 8 channels of balanced audio with grounds. Here's the wiring pin out for that. So they're in little triangles of 3 wires for each connection, for each channel of audio. So you can see that on the diagram. An XLR, this is going to cost around $3, $3.50, something like that. This, it still needs a shell around it, which I can show you. This by itself is going to cost less than $1 for 8 channels, so it's a lot more inexpensive. It's also just a lot smaller than 8 of these would be. So it allows you to put 8 channels in a much smaller area on your piece of equipment. And also ends up making the cables cost a lot less as well. So you're going to see these a lot on audio. This is the male. There's also a female that I don't have with me right. Oh yeah, I do. And then here's a female. This female is a PC board mount. This male is a cable mount. So those are DB connectors. So those are the main connectors we use for audio. Hope that gives you a little starting point for what they do and how to use them. Thanks.